Welcome. In this video, we're continuing a project from a previous video where we're recreating the classic arcade game Asteroids from first principles in JavaFX. In the previous video, we set up some of the core classes for our project. We have a class to store vector data, a class to store rectangles for collision detection, a class to store sprites, the images which could move across the screen, and kind of the core game class Asteroids. When we left off last time, we'd set up user input, and we have a spaceship which can fly across the screen, and once it travels off one part of the screen, it will reappear on the other side. Right, this is already pretty fun. However, in the game of Asteroids, at the very least, we're going to need the asteroids, which will also fly across the screen. And in general, the spaceship shoots lasers across the screen, so we should set those up as well. All right, so let's go ahead and close this down. Let's go back to our Asteroids project. All right, so what I'd like to do now is create a new array list. The space background and the spaceship, there's really only one of each of those. But as we introduce lasers and asteroids, we'll have multiple instances of each of those objects. So to keep track of a changing size collection of a certain type of object, I'd like to once again use the ArrayList class. Right, so I'm back in the asteroids class. I'm in the start method. And let's see, after we set up our input, we set up the background space, we set up the background for the spaceship. Let's set up two more array lists. These will each keep track of some sprites for us. Let's call one of them the laser list. That'll be a new array list, which can keep track of some sprites. Similarly, let's create an asteroid list. Array list of type sprite, call this asteroid list. And we'll initialize that. It's an array list of sprite objects. All right, so first, let's take care of having some lasers appear. All right, within the game loop, this will take a couple of passes to get correct. But let's say, for instance, I want to fire a laser whenever I press the space bar. And so as a first pass, we might try the following. If key pressed list dot contains space, right, in that case, we'd like to generate a new sprite. I'll call it laser equals a new sprite. From the images directory, we'll use laser.png. And for the laser object, we'll set its position. So laser.position.set. We'd like this to match the spaceship's position. So spaceship.position.x, spaceship.position.y. Right, we'd like the position, so it spawns at the same location as the spaceship. We'll also set the velocity of the laser as well. Let's say laser.velocity.set. Let's start off by saying, let's try laser.velocity.setLength. Maybe let's set that, lasers go pretty fast, maybe 400 pixels per second. And then the laser, for the velocity vector, let's set the angle to match the spaceship's angle. And so spaceship.rotation. So in other words, the laser spawns at the same position as the spaceship, and the velocity is going to move in the direction that the spaceship was moving. Right? When we press space, that will happen. And then we'll need to both update and render all of the laser objects. Right, so I'll do this with a couple of for loops. For each sprite called laser, I'll use the for each notation. in the laser list, what I'd like to do is laser.update. 1/60th of a second has passed. Then also, after rendering the background in the spaceship, let's also render all the laser objects. Right, so for each laser in the laser list, let's also say laser.render, and that's with the context object. Right, that sounds pretty good. Let's see what happens when we actually try to run this. And so let's say, give this a run. And here's our spaceship. Let's press the space bar. Huh, wait a second. Nothing's happening. Let's look at this for a second. We have our laser. Oh, you know what? We pressed the space bar key. We went through all that work of creating the laser, and then we just basically lost it because we never actually added it to the laser list. Laser list.add laser. So I'm wondering where all those glorious lasers went. All right, after adding that line of code, let's again try running this program. All right, let's press the space bar and see what happens. Look at that. Look at all those lasers. That is a lot of lasers. That is potentially too many lasers. Okay, so what's happening here? How did we get to this situation? The first problem is that as long as we hold down the spacebar key, we continue to spawn lasers. So we're spawning lasers at the rate of about 60 per second. Right, so we'd like a way to process, we would call this discrete input. So every time we press the spacebar key once and exactly once, we want to shoot a laser. The other problem is these lasers are lasting forever. Right, so we kind of want a built-in time limit after which we destroy the lasers. Right, maybe lasers last on the screen for 3 seconds or something and they disappear. So there's two problems that we need to solve to get laser fire to work appropriately. First, let's work on just firing one every time we press the spacebar key. Right, so we'll have to think about how we process input. Right, the key press list, space is part of the key press list as long as we hold down the spacebar. So since this is a different type of input, I'd actually like to set up a second list to store discrete input. The first list we created, key press list, this will be used to handle continuous inputs as long as key is pressed. I'd like to set up a second array list to handle what I would call discrete inputs once per key press. And so again, we'll create an array list of string objects, right, the names of the keys. I'll call this key just pressed list. And again, this will be a new array list containing strings which represent the names of the keys being pressed. All right, so on the main scene, we have an event handler, a listener here for whenever we have a key event, whenever the user presses a key. We go ahead and we add that to the key pressed list. What I would like to do is do the same thing for the key just pressed list. And so let's copy paste some of that code and let's add in the word just here. Right, so the instant you press a key, it gets added to both of these lists. However, for the just pressed list, we want to immediately erase that key once we've processed the input one time. What do I mean by that? Let's go down to our game loop and see how we're going to use this information. Right, so in the game loop, the first thing we do is we process user input. Right, I'm gonna be interested in the case where the key just press list contains space. Right, and after we process the user input, so after processing user input, clear the just pressed list. Right, so key just pressed list dot clear. Right, so whenever you press that, it's only going to be true for one iteration, for one call of the handle method. All right, that should actually be it. Let's go ahead and see if this fixes the problem where we're not shooting out a continuous stream of lasers, but just one laser per key press. So I'm going to go ahead and hold down the spacebar key. Oh, that's weird. Well, what I think is happening here, as you hold down a spacebar key, or as you hold down any letter key, that key continues to fire. Right? Imagine if we were back in the program here, right? What if I hold down a key like Z? First I get a Z, and then I get a whole bunch more. So this is actually triggering lots of key press events. So I need to think about how I'm going to process the key just pressed. All right, I think I remember what we need to do. So once we check the key just pressed list, we go ahead and we remove it from the just press list. The problem is we don't want to add it again. So let's go see when it gets added. Right, so set on key pressed. If key pressed list does not contain key name, let's go ahead and add it to both of the lists in this case. And let's talk about why we're adding it to both, but only checking if it's in the one list. Right, so set on key pressed, we're changing the structure of this a little bit. So the first time you press a key, right, it's not going to be part of the key pressed list, and we'll add it to both of these lists. Then we process the input once, and after processing the input, we remove the contents of the key just pressed list. However, until we release the key, until it gets off of the key pressed list, it can't be added back on to the key just pressed list. All right, let's go ahead and give this a run. Hopefully this will solve that issue. All right, preparing to fire, pressing spacebar. I'm holding down spacebar, and we've just got the one. Excellent. So now I can only fire one at a time. Granted, if I can mash the spacebar really quick, it'll still look like a constant stream. But this is an improvement. Right? The other problem we have to address now is, well, these lasers seem to last forever. Eventually, we've got a lot of laser garbage floating across the screen. It'd make a great screensaver maybe, but not a very good Asteroids game. So let's say we want these sprites to kind of self-destruct after they've been on the screen for a certain amount of time. Right, so what I'd like to do is keep track of how long a sprite has been on the screen. To do that, I'm going to go back to the sprite class. Right, in the sprite class, we keep track of a lot of data. We keep track of position, velocity, how many degrees it's rotated, boundary, image. Let's also keep track of a new variable in the sprite class. This will be a public double, and this will represent how much time has passed for this particular sprite. Maybe I'll call it elapsed time. Right, and this is going to be measured in seconds. When we initialize a sprite, we'll set elapsed time to 0. Right, when you first create a sprite, no time has passed. However, as you update a sprite, we'll update and increase the amount of time which has passed for this particular sprite. So scrolling down to the update method, let's increase elapsed time for this sprite. Let's say this dot elapsed time plus equals delta time. And so now elapsed time will tell us how long this sprite has been updated throughout the game. Now, why is that useful? Let's go back to our Asteroids class. And let's go specifically to the game loop. Right, in the game loop, we're updating the lasers, so each laser is keeping track of how long it's been on the screen. An additional thing we would want to do now is after updating the lasers, we probably want to remove any laser which has been on the screen for, say, more than 3 seconds, or whatever amount of time you feel is enough for the laser to live on the screen. Now, the tricky part is removing a laser or removing any object from a list. I can't really remove it from a list if I'm using this particular syntax. That would result in something called a concurrent modification exception. So if I would like to remove lasers from the list, what I need to do, instead, I'm going to go back to a more traditional for loop structure for int n equals 0. Continue as long as n is less than laser list dot size n plus plus. What I'd like to do is get a specific laser from the list. And so let's say sprite laser equals laser list dot get sprite n. And I'd like to update that laser. And then let's say if laser dot elapsed time is greater than 3 seconds, from the laser list, I'd like to remove that particular laser. So we could say that particular laser, or we could say the laser at position n. Right, either way is fine. All right. Let's go ahead and give this a run. Hopefully, this will cause the lasers to disappear after 3 seconds have passed. So let's go ahead and run. All right, I'm going to fire some lasers. 1, 2, 3. Maybe I'm counting too fast. 1, 2, 3, 4. All right, so it actually disappears after a while. So if I fire a stream of lasers, they're going to start disappearing after 3 seconds. Maybe 3 seconds is a long time. Maybe I want to make that a little bit smaller. But this is good. Lasers don't last forever. Right? That would make the game a little bit too easy if that could happen. Excellent. The next thing I'd like to do, after changing the laser elapsed time to greater than 2, I'd like to also add some asteroids to this game. Right, so I think at the very beginning here, right, we created something called an asteroid list. And let's go ahead and populate that with some number of asteroids before we begin the game loop. And so again, I'm in the right before the game loop. Let's say int asteroid count. How many asteroids do we want on the screen? We don't really need a lot to begin. For int n equals 0 and less than asteroid count n plus plus. What I'd like to do is go ahead and create an asteroid. Let's create a sprite called asteroid. It's going to be equal to a new sprite using, what do we call that image? Do we call it asteroid? No, we called it rock.png. Very generic name for an asteroid. So images.rock, or images/rock.png. I'm going to create an asteroid. Just like with the lasers, we want to give it some kind of a speed. We also want to give the asteroid some kind of a position, preferably far away from the spaceship. Right, the spaceship's kind of on the left side of the screen. I'd really like to set all the asteroids No, far enough away. Let's see. So let's create a double called x. This is going to be a random number. Math.random will give you a random number from 0 to 1. Maybe I want this to be, let's see, I'd like x to be to the right, maybe between 300 and 800. So that's a range of 500. I want to offset that by 300. So this gives me something in the range from 300 to 800 for the x-coordinate. For the y-coordinate, that can be anywhere on the screen, anywhere between, let's say, the height of the screen is 600. So maybe I'll start it off at somewhere between 100 and 500. That's a range of 400. Math.random plus an offset of 100. And I'll use that to set the position of the asteroid. So asteroid.setPosition, asteroid.position.set to be XY. So we'll have a little bit of randomness and replayability here. Let's also create a random angle too while we're at it. 360 times math.random. Since angles go from 0 to 360, let's say asteroid.velocity.setLength to be, it's got to be slower, maybe a little slower than the spaceship. I'll make them easy targets for now. We'll set the length of the velocity, so that's the speed. Let's also say asteroid.velocity set the angle to be that angle we calculated. All right, so we've initialized the asteroid with an image, a slightly random position, and a random velocity angle. Now we need to remember to add it to the asteroid list. Asteroid list.add this asteroid. All right, so we should have 6 randomly placed asteroids on the screen. Excellent. Now, within the game loop, what do we want to do next? We're going to update the spaceship. We update the lasers. Let's also update the asteroids. And the asteroids aren't going to get destroyed quite yet. All right, so let me put in some comments too for what we did last time. Update lasers destroy if more than 2 seconds have passed. I also want to update all the rocks as well. Let's see, so for each sprite called rock, now let's be consistent. For each sprite called asteroid in the asteroid list, say asteroid.update. Right, this will apply the velocity. It also applies the wrap function. So we're updating each of the asteroids. And then we also want to render each of the asteroids as well. Right, so that's going to be very similar to this list. And so we're rendering lasers, we're rendering asteroids. Each asteroid from the asteroid list. Ask the asteroids to render themselves using the context. All right, so if this goes according to plan, we should see the asteroids render themselves. Let's go ahead and give this a run. Hey, look at that. We've got asteroids. And shooting them does nothing. That's okay. We'll add that next. All right. But this game is coming along. This updates lasers and destroys if 2 seconds have passed. So let's say we also want to check for whether a laser overlaps a rock. So when laser overlaps an asteroid, we're going to go ahead and remove both. All right, in this case, again, since we're removing things from lists, sadly, we can't use this nice condensed form of the for loop. So we're going to go ahead and create a nested for loop. Let's say for int laser number equals 0, as long as laser number is less than laser list dot size, laser number plus plus. Right, within this for loop, we're going to need a nested for loop. Let's say for int rock number equals 0, or again, let's be consistent. Asteroid number equals 0. Asteroid number less than asteroid list dot size. Asteroid number plus plus. I'll make this a little bit smaller so we can see the whole line of code. All right, so we have lasers and asteroids. Once we have the laser number, we can actually create a sprite called laser and get that from the laser list. Laser list.get laser num. The same thing, once we've established the asteroid number, we can retrieve that sprite. So sprite asteroid equals asteroid list dot get asteroid number. And then we want to check to see if the laser dot overlaps the asteroid. Then, well, a couple of things we need to do. We need to remove both the laser and the asteroid from the game. Let's say laser list dot remove a particular laser number, and asteroid list, let's remove the asteroid number. All right, so there's the destruction between the asteroids and the lasers. All right, let's go ahead and give this a run. Hopefully we can now shoot those asteroids and they get destroyed. Hey, look at that. Take that, asteroids. So where'd you go? There's one. And, oh, miss. There we go. Nice. I feel like the asteroids champion. All right, the next touch I'd like to add is some kind of a scoring mechanism. Right? At this point, we destroyed the asteroids, but it's always nice to get a little bit of feedback. For example, maybe some kind of score or point mechanism. Right? In this case, I'm going to declare a score variable, but I actually need to do that outside of the start method. It's because I'm going to use an int for this score. Right? Because the score isn't technically an object, so there's an issue with changing the value of score within the handle method of our animation timer, unless it's a final or effectively final. Okay, so let's see, let's initialize the score down here. And let's say score is equal to 0. And then within the game loop, every time we destroy an asteroid, we'll get some number of points. We'll add something to the score. And so heading back down to this, when laser overlaps asteroid, right, after we remove both of those objects from their lists, let's also say score plus equals 100. We get 100 points. Now it's great to get points, but we also need to know how many points we have. And for that reason, we should try to display that on the screen somewhere. So what I'd like to do, after rendering all of these objects, I would also like to draw some text on the screen. And so I'll start off, let's say context dot, let's set the fill color to be maybe white. And maybe let's make this look fancy because we can. Let's set the stroke color, kind of like an outline for the text we're about to add, to be a nice green. Maybe something brighter. Now let's try green. All right, what I'd like to do is to draw some text. And the text is going to be, let's say, string text is equal to, let's say, score plus whatever the actual value of the score is. Let's say we want to render this text at some point. Let's say int score, let's say text x for the x position. Let's see, this is going to be technically the bottom left corner of the text object. If I want to put this on the right side of the screen, maybe I would put that, let's see, 800 pixels wide. Let's start off with 600 and int text y, not too far down, so maybe 80. In addition to setting the fill and stroke color of the text, let's also set the font. Context.setFont to be, let's see, a new font object. Let's see, how do we do this? Say new font. I think we just put in the name of the font we want. This has to be the name of a font installed on your system. So I'll say maybe Arial Black, size relatively large. Maybe I'll try a 48-point font. Oh, and I need to create, or I need to go ahead and load the font class. All right, so we're going to set the font. Let's also set kind of a thick border as well. Context.setLineWidth. By default, it's only 1 pixel wide, but let's try maybe 3. Finally, on the context, I want to do the fill text, text at the X and Y positions we just stated. And let's also do a stroke text to get a nice kind of outline effect for that as well. All right, so all of this code right here is to draw, score on screen. Right, it's pretty long, but that's because I want it to look pretty good. Right, so we're setting both interior and outline color, choosing our own font, choosing the width for the border, setting up the text and the position. I declared these as variables just because it'll be easy to repeat the code here. We actually have to call fill text and stroke text separately. One does the inside color with a fill, and one does the border color with a stroke. All right, I'm not sure about the placement of this, but let's go ahead and save and give this a run and see if we can see the score on the screen. Hey, sure enough, I see the score on the screen. The placement isn't super great. I do want to move it a little bit to the left, maybe a tad bit higher up. That's not too bad. Maybe I'll make this 500. Maybe I'll make this 50. All right, run that one more time. All right, I could play with that some more, but for now, if I shoot something, hey, I get some points. That's great. I want points. Let's go ahead and spin around. There we go, 600. At this point, hey, I should win the game. Well, we've made a lot of good progress on this game. In this video, we learned how to add discrete events. We were able to improve our sprite class a little bit more. We're able to shoot things. That's always fun. Right, there's a few more features that you could add to this game later on if you wanted to. Like, for example, you could fine tune, you could add more asteroids, you could change their sizes. You might want to have a you win message appear if you destroy all the asteroids. Similarly, one feature which we probably should have in this game, but we don't have at present. If the spaceship collides with an asteroid, that's not a good idea. We should also check for collisions between the spaceship and the asteroids, and if that happens, maybe destroy the spaceship, and then we lose the game. And then we can no longer fire lasers or anything like that. So having a clear game win and game lose message appearing at the appropriate times and registering collisions with the spaceship and the asteroids. But we've made a lot of good progress working together. Thank you for listening, and I hope you enjoyed learning how to make asteroids from first principles in JavaFX.